Hello, my name is Bill Hyatt, and we're going to be discussing two important water properties, viscosity and density, that are very critical to clarifiers that are part of water treatment plants and wastewater treatment plants, and some of the consequences of that. Our subjects are going to be the density and viscosity of water, and we're also going to talk about lake stratification and the Gulf of Mexico hypoxia situation, otherwise known as the Gulf of Mexico dead zone, which is the result of low oxygen levels in the Gulf, and some information about the density of other materials. This information from this video come from these websites. The density of water varies slightly, but significantly between as a function of temperature. And for our purposes, the density at the lower temperatures from 20 degrees to 0 are the most important. The density reaches a maximum at about 4 degrees centigrade, and then is slightly lower. This is very important from the aspect of lakes and water. The other parameter is the viscosity. So you can see it also varies substantially over a large temperature range, and from 20 degrees to 0 ranges from 1 to 1.8 centipoise. In the summertime, we all know that warm water is at the surface and cooler water is at the bottom, and sometimes we walk or swim into deeper areas and can notice a substantial difference in the temperature. In the fall, as things cool down and temperatures cool off, and the water column can be completely mixed with a little bit of wind agitation or currents. And this is a turnover, and this is very important for water treatment facilities because the suspended solids in the water can go from practically 0 to several hundred overnight. Later in the winter, ice forms at the top, as we all know, ice floats, and the coldest water is at the top, and the warmer water at 4 degrees centigrade is at the bottom. In the spring, as the ice melts and the water warms up, you have another turnover. This is the study of limnology, just a small aspect of limnology, which could be a very interesting and important career choice for certain people. Next, we're going to talk about the hypoxic zone in the Gulf of Mexico. As I'm sure you all know, the Mississippi River is one of the largest rivers in the world, certainly the largest in the United States. Interestingly, I grew up right in this neighborhood at the edge of the watershed, and I currently live right here in the mountains of North Carolina, also quite near the interface of the two watersheds. Another important aspect of the Mississippi River Basin is that a large percentage, like 30 to 40% of the Mississippi River flow, is diverted from the main channel into the Atchafalaya River north of Baton Rouge, and is then discharged into the Gulf of Mexico slightly west of the primary delta opening. The hypoxia in the Gulf of Mexico is a result of nutrient growth, nutrient-sponsored growth of plankton and algae that settles to the bottom and depletes the oxygen. As you may know, phosphorus is the primary rate-limiting nutrient in freshwaters, but nitrogen is the typical rate-limiting growth nutrient in seawater. I was a member of the Nutrient Task Force on the US EPA Gulf of Mexico Hypoxia Task Force because my company discharged a number of millions of pounds into the Mississippi of nitrogen into the Mississippi River. So I was a part of this for several years. So what you see here is the picture of the hypoxic zone in 2015. The cause of the hypoxia is actually a density function. When the fresh water flows into the Gulf in the summertime, of course the Gulf is warmest in the summertime, but it's also very stable, or relatively stable, with low winds. So the fresh water flows out into the Gulf and forms a layer over the top of the seawater, blocking the transfer of oxygen. So in the shallow Gulf waters, shallow meaning 100, 200 feet, 300 feet, the oxygen can be depleted. Most of the swimming organisms will voluntarily move from this area, but shrimp and other crustaceans and non-mobile life forms are severely impacted. This view shows the hypoxic zone in 2014. And you can see that it is approximately the same type of situation. Here we have a chart showing the number of kilometers, square kilometers, experiencing hypoxia from 1985 to 2014. And you can see that it's typically around 15,000 square kilometers. The task force goal is 5,000, so well above the task force goal. And of course, the actual goal is 0, but that no one believes that is attainable in any time frame. Okay, we'll finish our discussion with some information about density of materials. Naturally, water is approximately 1 gram per cubic centimeter. Bacteria are very close to that. A commonly used filtration as sand filtration is used in nearly all water treatment plants. Sand has a density of 2.85. Also, multimedia filters, 2 or 3 layers, are commonly used. And in those filters, you use particles of different size, and they include sand, anthracite at 1.6, and garnet at 3.8. The bacteria are only slightly heavier than water. They consist of mostly water and similar fluids. And for the bacteria are also typically very small, as you know, of the order of magnitude of 1 micron, and they flocculate into masses, and that's the effective way of settling them. For information, plastics vary somewhat in density from less than the density of water, where they float, or polyethylene and polypropylene, to over the density of water for plastics such as ABS, nylon, and polyester. I've listed a number of metals here: aluminum, iron, copper, silver, and so on. And you can see at the bottom of the list is gold. And you all may remember the long history of Archimedes, who, sitting in the bathtub, developed a method of measuring the metal content of precious metals. So that concludes our brief discussion of density and viscosity, and I hope that's interesting. Goodbye for now.